Here are some rules for differentiation. To differentiate means to find the derivative. The first rule is the derivative with respect to x of any constant is 0. Second rule, the derivative with respect to x of any constant times x is the constant. Rule 3, the derivative with respect to x of any number times x raised to any number is the number up here, the exponent, times the number out in front here, the coefficient, times x, just copy the x, raised to the exponent, original exponent minus 1. In these rules, the c, the m, the n, the p all represent any constants. X is a variable. And we say the derivative of whatever with respect to x. This is the notation. On page 155, exercise 76, y equals negative 1/3 x to the third plus 6x to the second minus 11x minus 50. We're going to find the derivative of y with respect to x. We could also symbolize that y prime. There's 4 terms here. We're going to differentiate term by term. Differentiate just means find the derivative. The first term is a number times x to a number. The derivative is the number up here, the exponent, times the number in front here, the coefficient. Copy the x, and the exponent becomes 2, 1 less than what it is originally. Same rule for the next term. The number up here is 2, multiplied by the 6, copy the x, the exponent 2 becomes a 1. For both of these terms, we used this rule. The next term, we're going to use the middle rule here. A number times x, the derivative of a number times x is just the number. Example, the derivative of negative 11 times x is negative 11. And the last term is a constant. That's the first rule. The derivative of any constant is 0. The derivative of negative 50 is negative 0. Or positive 0, doesn't matter. So this simplifies to negative 1x squared plus 12x minus 11. So the question here is to find the points on the graph of the original function where the tangent line is horizontal. A tangent line is horizontal when its slope is 0. So the key concept here is the slope of the tangent line is the derivative. The slope of the tangent line is the derivative. the symbol for this word, the symbol for is equals, and there's a symbol for that word. So we're going to solve this equation for x, use some algebra. I divided both sides by -1. This left side can be factored, x minus 11, x minus 1. If you couldn't think of the factors here, you could use the quadratic formula. This is equal to 0 when x minus 11 equals 0, or when x minus 1 equals 0. So x equals 11, x equals 1. When x is 11, y comes out to be 111 1/3. I'm not showing how to get that. I'll just say how to get it. You take that 11 and plug it in up here, since this says what y equals. Plug 11 in for x in your calculator, and you'll get the y. And then when x is 1, y is -55 1/3. So the question is, find the points on the graph at which the tangent line is horizontal. That would be at the point 11, 111 1/3, and also at the point 1, -55 1/3. Number 60 says y equals x squared minus the square root of x. Same as y equals 1, x squared minus 1 times x to the 1/2. The derivative of y with respect to x is this number up here times this number here. Copy the x, and the 2 becomes a 1. Same rule here. This number here gets multiplied to this number. The x gets copied, and the 1/2, whatever the exponent is, we have to take away 1. Just like this 2 became a 1, this exponent becomes this exponent. That's the same as, this is the same as 2x minus 1 over 2 radical x. This simplifies to that. The derivative is the slope of the tangent line. In the question it says find the tangent line at the point 1, 0. We find the slope of the tangent line by putting this number in place of x. Everywhere there's an x, I put a 1 because we want the tangent line at the point where x is 1. That's equal to 2 minus 1/2, which is 1.5, or 3/2. The equation of a line, this is the equation of a line. The equation of the tangent line at the point 1, 0 is y minus 0. For y1 we're using this number, equals m. For m we're using the slope of the tangent line, parentheses x minus 1. X sub 1 is that number right there. Y minus 0 is y. Distribute 3/2 times x minus 3/2 times 1. And there's the answer. That would be the line that's tangent to the given function, tangent to this function at 1, 0. And that looks like this. Here's y equals x squared minus the square root of x. It's blue. This red is the answer we just found. Y equals 3/2 x minus 3/2. Notice the red line is tangent. That means touching blue curve at 1, 0. Here's two more rules for finding derivatives. There's the product rule, which says that derivative of a product is the first times the derivative of the second plus the second times the derivative of the first. You're going to want to memorize these words. You can write the rule, the product rule, in symbols, but it's better to memorize these words. I'm also going to write down the quotient rule. Here's the quotient rule in words. The derivative of a quotient is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. All over the denominator squared. I do need to memorize this sentence. The derivative of a quotient is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. I'm going to do two examples, but each example I'm going to do twice. On page 163, exercise 6, f of x equals 3x to the fourth times x squared minus 4x. I'll underline the first in red, or circle the first in red. And I'll circle the second in blue. F prime of x, which is the symbol for the derivative, is the first times the derivative of the second plus the second times the derivative of the first. And that's it. This is the product rule. The derivative of a product is the first times the derivative of the second plus the second times the derivative of the first. In a simpler form, this is distributing 6x to the fifth minus 12x to the fourth plus distributing the red into the blue, 12x to the fifth minus 48x to the fourth. Now that we've distributed, there are some like terms. 6x to the fifth plus 12x to the fifth is 18x to the fifth, and negative 12x to the fourth And negative 48x to the fourth is negative 60x to the fourth. That's the answer. Now this exercise can be done without the product rule, because f of x equals 3x to the fourth, parentheses x squared minus 4x. F of x is the same as 3x to the sixth minus 12x to the fifth. So without using the product rule, the derivative is 6 times 3 times x to the fifth minus 5 times 12 times x to the fourth. So there's the same answer that we got here doing the product rule. 18x to the fifth minus 60x to the fourth. Same thing. Number 18, f of x equals x to the third plus 27 over x plus 3. I'll circle the numerator with red and the denominator with blue. This is called a quotient. The derivative of a quotient is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. The derivative of a quotient is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. F prime of x equals, distributing here, we have 3x cubed plus 9x squared. This minus distributes into the red, and so does this 1 minus x cubed minus 27 all over x plus 3 squared. Three x cubed minus x cubed is 2x cubed. So we have 2x cubed plus 9x squared minus 27 all over x plus 3 squared. So we will talk about trying to simplify that. But in the meantime, we're going to do this problem another way. This is number 18 again. If you know that x cubed plus 27 is the same as x plus 3 times x squared minus 3x plus 9, then you'll know that this original fraction is the same as x squared minus 3x plus 9 because of canceling. And now the derivative is easy to find without using the quotient rule. The derivative of 1x squared is 2x to the first. The derivative of a number times x is the number. And the derivative of 9 is 0. So a question to ask would be, when we used the quotient rule, we got this answer. And when we simplified first and then found the derivative, we got this answer. So are these two answers equivalent? That's something to think about. If they are not equivalent, then one of these sides has a mistake. Okay, there's one more rule for this video, which is called the chain rule. And it says this: if y is equal to some number times something, some function with x in it, raised to some power, some exponent, then the derivative of y with respect to x is found doing four things. You have to do four things to get the answer. The first thing is the exponent and the number in front have to be multiplied. The second thing is this u, whatever is in here in the parentheses, has to be copied. Just copying that. The third thing is this exponent has to be reduced by 1. That's only three things. The last thing is we multiply all of that by the derivative of whatever is inside the parentheses with respect to x. This last part here at the end is the fourth thing you do. Multiply, copy what's in the parentheses, subtract 1 from the exponent, and multiply by the derivative of what is in the parentheses. An example is if y equals 5 times 2x squared minus 3 to the second power, we're going to find the derivative of y with respect to x. There's four things. 2 times 5 is the first thing. Whatever's in the parentheses gets copied. That's the second thing. The 2 exponent becomes a 1. That's the third thing. And the last thing is we multiply by the derivative of whatever is inside here. The derivative of what's inside here is 4x minus 0. So that's the answer, or it could be written as 40x, multiplying these two, times 2x squared minus 3 to the first power. Or distributing, it's 80x to the third minus 120x. We call this the chain rule. The four things: 1, 2, 3, 4. And we're going to do this problem one more way, another way, and then we'll be done with this video. So same given function. So let's say you did not know the chain rule that we just demonstrated. You do know that 2x squared minus 3 squared means 2x squared minus 3 times itself. And you do know that 2x squared minus 3 times itself is 4x to the fourth minus 6x squared minus 6x squared plus 9. And that 5 times all of that is 20x to the fourth minus 30x squared minus 30x squared plus 45. So y equals 20x to the fourth minus 60x squared plus 45. So now that all of this algebra is done, rewriting the given function, the derivative of y with respect to x is this 4 times this 20 times x to the third, this 2 times this negative 60, times this x to the first, plus 0, because the derivative of 45 is 0. And we're done. Notice the same exact answer. This is the answer obtained using the chain rule. This is the answer obtained by first rewriting the given function without any parentheses, and then finding the derivative.